Let's discuss about the focal length formula for thick lens. Here this is given the focal length formula for the thick lens, where 1 by f is focal length, f is a focal length, mu is a refractive index of the material of the lens, thick lens, 1 by r1 is a radius of curvature of first surface, 1 by r2 is a radius of curvature of the second surface. Mu1 minus mu1 and t is the thickness of our lens, and r1 is the radius of curvature of this surface, and r2 is the radius of curvature of this surface. So this is a simple ray diagram of the thick lens, where we are assuming a parallel ray coming from the infinity and its distance from the principal axis, which is P1, P2. It is a principal axis of this thick lens system, and incident on the first surface. From there it goes up to first principal plane, and then, as we know, if some light comes from the infinity and incident on the lens system, it will emerge through the second focal point. Okay, from f2. So our aim is to find out the focal length of this system. Here h1, h2 is our principal point. Let's h1 is the distance from the optical axis, principal optical axis, and this is P1 and P2, where it discusses the principal axis. This is two principal points, and this dotted vertical line is a principal plane, first principal plane, and this is second principal plane. So if this surface is not there, absent, if based on this single surface, then what happened? Light will come from the infinity, cut it here, and it will coincide with the principal axis at some point S. Okay, and if second point is there, then it will not go up to this point, it will emerge from this focus point. So let's decide this point is our T, PQR. Let's decide it is R, and distance of R and P2 is S2, and H1 is a distance from coming rays and with the principal axis. So first we'll decide to put the formula for the reflection from the first plane. For this, formula is mu2 by p minus mu1 by u equals to mu2 minus mu1 divided by r. For this, mu2 equals to mu and mu1 equals to 1 because we are taking length of the refractive index mu, and this is the air, means our lens is kept in the air, and v equal to p1s and u equal to infinity because we are taking object kept at the infinity because we are getting the parallel lights. Put in the equation and what we will get, mu by p1s minus 1 by infinity equal to mu 2 minus mu1 upon r1. Solve it. Mu by p1s equals to mu minus 1 by r1, that will give us mu by simple equation, and put it as a equation number 1. Okay, this is, I have rewrite this equation here and put only mu to this place, and we'll get the 1 by ps equal to mu minus 1 upon mu r1. Okay, then put the refraction formula for the second surface. For that second surface, what will happen, the light came from this point, and image for this surface, light came from this point and emerged from this point, focal point, and this point is imaginary for this second surface, and this point is object and this point is image. So for that we put the constant for this surface, mu2 is equal to, then we put the refraction formula for the second surface. For second surface, mu2 will be 1, mu2 image because image making image in the air portion, and mu1 is mu, and v is for v, that is equal to p2s, p2f2 v, and u is p2s, p2s. Okay, so just put these values into the refraction formula. 1 upon p2 f2 minus mu upon p2s equal to 1 minus mu upon r2. Rearrange this equation. p2 f2 equal to 1 minus mu upon r2 plus mu by p2s, and put it equation number 2. Then our next target is putting all vertical distances in the form of horizontal distances. It means we are now putting all the vertical constant in the form of horizontal. So let's consider two triangle of the same angle, triangle Q P1 S and R P2 S, where this angle is same in these two triangles. So we put the condition for the same angle condition, and second is we take the different triangle. This we are putting PQR and make it as some other constant. So first let's consider triangle Q P1 S, triangle Q P1 S and triangle RP2S, RP2S. Here what happened? H1 by H2 equals to H1 by H2 equals to P1s divided by P2s. And second, consider triangle TS2S and RP2. No, not this one. Consider TS2F2 and triangle RP2F2. Let's consider TS2F2 and triangle RP2F2. RP2F2. In this case, we can see this distance is same as this distance and same as this distance. So this distance is also h1 and this distance is h2. Okay, so what happened in this triangle TS2F2 and triangle RP2F2, h1 by h2 equal to h2F2 divided by P2F2. Okay, this H1S2 and this H1S2 both are same, left hand side is same, so right hand side should be also same. So I can put P1S equals to P2S. From the cardinal point concept, what happened? This second principal point and F2, that is called focal length. It means this distance is focal length. I can put S2F2 equal to F in this equation. S2F2 is equal to F. Means S2F2 equals to F. Previous equation number 3, I can take S2F2 is the right hand side and P1 is upon P2S, and this is 1 by P2. F2 is equal to 1 by F, P1S and P2S. So by equation 2 and 4, what happened? Put all the values here. Mu by P2S plus 1 minus mu on R2 equal to 1 by F, P1S and P2S. So 1 by F equal to mu upon P1S plus 1 minus mu upon R2, P2S upon P1S. That's equation 5. If you see our figure, P1, P2 and S, what happened? P1, P2 that is equal to T. Okay, then I can write P1S equals to T plus P2S, and P2S is equal to P1S minus P1P2, and P1P2 is equal to, this is nothing but that is thickness of the lens, and I am taking this as a 6. So what happened? Question number 5, 1 by F equal to mu upon P1S plus 1 minus mu upon R2, P1S minus T upon P1S. I just solve this equation. Okay, and just rearranging the equations. I just take P1s divided by this and minus T upon P1s. 1 minus T 1 by P1s. I put the P1s value from equation number 1. P1 value. Put the value P1s. That is nothing but what? That is mu minus 1 divided by mu R1. Okay, then our equation becomes 1 by f equal to mu minus 1 upon R1 plus 1 minus mu upon R2, 1 minus T mu minus 1 upon mu R1. After cutting, after a small calculation, what will happen? Mu minus 1 upon R1, that is 1 by f, mu minus 1 upon R1 plus 1 minus mu upon R2 minus 1 minus mu upon R2 T mu minus 1 on mu R1. So let's take outside mu minus 1, what if 1 by R1 minus 1 by R2 plus mu minus 1 T upon mu R1 R2, and this is the formula of focal length of thick length or thickness T.